pleasure of introducing Professor Lars Alfredsson, who serves as Professor of Epidemiology at the Institute of Environmental Medicine at the Karolinska Institute in Stockholm. His main interests are in understanding how environmental factors interact with genetics, with special reference to inflammatory diseases like MS and rheumatoid arthritis. He's currently running several large epidemiologic studies and is the former head of the Research Education in Epidemiology at the Karolinska Institute. Professor Alfredsson has authored over 500 original scientific publications and is among the top 1% most cited researchers in the world, according to Claravit. Today, Professor Alfredsson will be speaking to us about smoking and organic solvents in MS.
Thank you for that nice introduction, and I thank the organizers for having invited me here to give a talk about smoking and organic solvents in relation to MS risk. What I will be talking about is, I will go through a little bit what we know about smoking and organic solvents in relation to MS risk. And also I will ask the question whether these exposures interact with the two most important MS-associated risk genes, and also whether organic solvents and smoking interact by themselves, and a little bit on what are the implications of such interactions if present. Smoking has, in a large number of studies, been found to be associated with an increased risk of MS, and in a late meta-analysis from 2017, they found that the odds ratio is about 1.5, roughly. And there is also another one this was most based on 34 studies, then this other guy here came up with, so looking on the 26 studies with the best or the highest quality, and they also found around 1.5. It has also been noted that there is a significant dose-response relationship between pack years of smoking and MS risk, that both intensity and duration plays a role. And also importantly, that quitting smoking abates the risk. So I will go through a little bit details regarding this, and based from our Swedish studies, we have two big case control studies which are population-based. One is called Epidemiological Investigation of Multiple Sclerosis, AIMS, and the other one is called Genes and Environment in MS, GEMS. And altogether they comprise about 9,000 cases and 12,000 controls. And the aim with both studies is to study environmental and genetic factors and their interaction. So when we look on how what the pattern looks like when we look on the dose, we have number of pack years here and odds ratio. We can see that it's a steady increase here with the number of pack years. And if you have smoked 16 pack years or more, you have nearly twice the risk to develop MS compared to never smokers. And interestingly, we have also noted that both intensity in terms of cigarettes smoked per day and duration in years play a role. If you look first on these two rows here, where you have smoked less than 10 years, we see that intensity does matter. But, which is very interesting, I think, if you have smoked for long, then intensity seems not so influential anymore. So even if you have smoked less than 5 cigarettes or less than 6 cigarettes per day for more than 10 years, you are about twice the risk to develop MS compared to never smokers. And this opened up, I think, also for other and airborne exposures, since it does not, you don't have to have so high intensity if it's, the exposure is long. And also, we have seen evidence that if you quit smoking, then the risk to develop MS decreases, and after 10 years, you are back to the baseline risk again. And both these observations, that there is a dose-response relationship and that the risk abates after quitting smoking, also adds to the notion that smoking really is causally related to MS risk. There is another also interesting information here, that snuff use that share nicotine with cigarette smoking but not so much else, snuff use decreases the risk to develop MS. And that means that it is likely not the nicotine that is harmful in relation to MS. It's rather the other substances in this cigarette smoke that are harmful. So let's then move over to organic solvents. And here there is a meta-analysis based on 15 studies finding an odds ratio of 1.5. That is about the same order as for smoking. And this is occupational exposure to organic solvent, I would say. And there is a later meta-analysis based on the 14 studies published after 1988, finding about the same thing. If you look on the confidence intervals, they are pretty similar. The only study that have looked on those responses I'm aware of is the AIM study, where we found a statistically significant trend showing an increasing MS risk with duration of exposure as well as total hours of exposure per week. So both intensity and duration seems to be related to the risk. So let's then switch to gene-environment interaction. It's known that both environmental factors and genetics are involved in the etiology, and thus we have to take lifestyle, environmental factors, and genetics into consideration in our studies. The problem is, though, that there are the genetic fields and the epidemiological fields have been operated rather separately, so there are rather few studies where they have both information on environment and genetics. So both our AIMS and GEB studies has that, and there are other studies as well which we try to collaborate with. But first, why is it of importance to study interactions? Well, interaction may inform about mechanisms of disease. You can show that if two causal factors interact on the additive scale, then they take part in the same causal pathway towards disease, also called sufficient cause interaction. Another way to frame this is that there are persons in the populations that would not have had the disease if they were not exposed to both interacting factors, if interaction is present. There are a number of measures to evaluate the presence of interaction. Here you have 3 of them. The first one, the attributable proportion due to interaction, is perhaps the most easy to verbalize. It is the proportion of cases among those double exposed, those who have both interacting factors, that are attributable to the interaction per se. So it's a percentage between 0 and 100. So if you have an attributable proportion of 30%, then 30% of the cases among the double exposed are due to the interaction per se. We have looked upon the interaction between the two HLA alleles. Here we have the HLA DRB11501 with an odds ratio of 3.5, and it is known that presence of a HLA-AU2 confer a protective effect with an odds ratio of 0.6. When studying interactions, due to technical reasons, you have to do it between risk factors. So then we have to switch from presence to absence of HLA-AU2, and that will have an odds ratio of 1.7 instead. So here is the first study looking on this interaction. Here we have the four different combinations. If you combine presence and absence of these two genetic risk factors, so here we have those with the highest genetic risk, and here those with the lowest, and current smoking and never smoking. And we can see that current smokers with the highest genetic risk have nearly 20 times the risk to develop MS compared to never smokers with the least genetic risk. So if we take both genetics and smoking into consideration, the pattern becomes more complicated, and you can see very high effects here. Looking on the interactions, we see that there is an interaction, significant interactions between smoking and both these genetic risk factors. Later, we have replicated this finding by combining 4 Nordic materials. And once again, they have the 4 combinations here. We have current smoking and never smoking. And the odds ratios are not quite as high here, but once again, there is a significant interaction between smoking and both these. But then we may ask ourselves, what about passive smoking or environmental tobacco exposure? There has been 4 studies on the topic, and if you combine them, you find an odds ratio of 1.24. We have done this analysis in our AIMS study, which I think is the material which has the best information on this. Here we see a table where we have looked on all never smokers, so everybody's a never smoker, and we have asked all the cases and controls whether they have been exposed to passive smoking at home, 1 question, or at work, another question. And then we have the duration in years here. And if we look here on the adjusted odds ratios here, adjusted for a number of potential confounding factors, we actually see that there is a significant association between passive smoking and MS risk, nearly as high as for smoking itself. It was surprising. And we also see those statistically significant dose-response relationship here. So how about when combining with the genetics here? Well, we see here still in the AIM study that there are signs of interaction. Here we have worked together with an American material. It's a Kaiser Permanent Northern California case control study run by Lisa Barcelos. And we see similar patterns between the 2 studies. And calculating the interaction here, we see significant interaction between passive smoking and both these genetic risk factors. So then, what about organic solvent? Do they behave in the same way? Well, first of all, the meta-analysis found 1.5 as an odds ratio once again, and that is what we see in our AIM study as well, 1.5. Now combining with the genetics here, the picture becomes more complicated since we know that smoking interacts with these. Then we have to take smoking into consideration at the same time. So we have here done that by having 4 combinations of smoking status and organic solvent exposure status. And we can see signs of interaction, and what stands out is this extremely high relative risk here among ever smokers exposed to organic solvents with the highest genetic risk, once again compared with those with the least genetic risk, which are never exposed to any of these. Calculating the interaction between organic solvents and these genetic risk factors, we have done it separate among never smokers and found such interactions, and we have done it among smokers, and you found that they interact as well. So organic solvents interact with each of these genetic risk factors. Then we asked the questions whether these 2 airborne lung exposures interact by themselves. And then we, of course, have to take the genetics into consideration. So we have an analysis where we look on those with the highest genetic risk. So here everybody has both genetic risk factors. And we have smoking and organic solvents. And if you have been exposed to both smoking and organic solvents, you have 7 times the risk to develop MS compared to never smokers without organic solvent exposure. And calculating the interaction, it's high, it's 70%. Doing the same calculations among those with without both genetic risk factors, we don't see any significant interaction. So these 2 lung exposures interact in the context of high genetic susceptibility. So we have also, are right now conducting a study on air pollution. So we have done that by looking on combustion-related air pollution. And we have done that by doing first a register-based studies where we have included all cases during a period of time in Sweden. You can find in all studies, registers everywhere. And then it's about 22,000. And we have randomly selected controls from the population registers matched on the age and sex. And then also by means of registers, you can trace the residential history over time. And we have collaborated with the weather authorities that can link to each address air pollution levels. So we have been able to do that. But the drawback with registers is that you don't have any lifestyle habits or genetics. But since the AIMS and GEM studies are included or embedded in this, we can perform a sub-analysis in those. And key findings are that combustion-related air pollution measured by high nitrogen oxide levels, NOx, 3 years before index. Index is a year of onset of first symptoms for MS cases and similar for controls. We actually saw a increased risk, which was also dose dependent, and we saw a synergistic effect between NOx levels and DAB1 1501, and likely also for A2. We are analyzing that right now. So, conclusions. We have seen a pattern here, and it seems like different sources of lung irritation contribute to the development of MS, especially among subjects with the genetic susceptibility, and hypothetically due to non-specific lung irritation with activation of CNS-specific autoreactive T cells with a pro-inflammatory bias. Or another possibility would be that the lung irritation introduces post-translational modifications of proteins in the lungs that are cross-reactive with CNS antigens, as has been seen in rheumatoid arthritis. So I just want also to thank all collaborators that has contributed to this, and I thank you for your attention, and I'm happy to take questions afterwards. Thank you.